We are going to talk about how to prove triangles congruent. So we already know that if all the corresponding angles and all the corresponding sides are congruent in two triangles, then the triangles are congruent to each other. We already know this, right? Okay, but in the next few sections, we're going to see that, you know what, that's a little bit of an overkill. So for example, if I have this one triangle and if I have this other triangle, yes, if these two are congruent and these two are congruent and these two are congruent, right? And same with the sides. All right. Yeah, if all 6 here are congruent to all 6 there, the triangles are congruent. But we're going to see that, you know what, you don't need all 6 of those things to be congruent. Sometimes you can get away with just 3 of them if it's the correct combination of 3. So that's what we're going to do in the next few lessons. Okay. The first thing we're going to learn is this postulate. It's called the side congruence postulate. It's got a nickname, SSS. So we just call it the SSS postulate. Okay, the SSS postulate says, if the sides of one triangle are congruent to the sides of a second triangle, then the triangles are congruent, right? So already, we don't need to know all 3 sides and all 3 angles are congruent. We could just get away with all 3 sides being congruent. That's SSS. So if you look here, if this side is congruent to this side, and if this side is congruent to this one, and then this last one is congruent to the last one, then we say the triangles are congruent by the SSS postulate. Okay? So we're given this here, right? These 3 sides are congruent to those 3 sides. Let's see which triangles are congruent. Okay. So I'm going to say triangle, right? And you start with one of the vertices. So let's say I'm going to start with this I. Okay? I, H, so triangle I, H, and look at what I did here. I, H. That's the side with one tick mark, right? That's the side with one tick mark. And then I said IHG. Is that enough to say the name of that triangle? Yeah. It is, right? I've given the 3 letters. So when I go to give the name for the other one, it's going to be triangle what? So here it's IH. In what order did I do IH? Yeah. The one with the one tick mark, but also look, I started from the one with the 3, leading up to the one with the 2. LK. So LK in that order, right? LKJ.
Also, the L has like a pointier thing, so does the L.
Right. Sometimes you can do that. Sometimes you can't, because the triangles don't need to be drawn to scale, yeah. Right? So always go with the corresponding parts, okay? Okay, yeah.
So if, let's say it's 2 triangles, 2 equal sides, would that mean the third is also equal?
Not necessarily. All right. Okay, let's do this lesson and maybe that'll pop up, okay? All right, so determine whether triangle RTZ is congruent to JKL. And we're given the coordinates. So first, what I'm going to do is draw these. So let's draw triangle RTZ. So R is at 2, 5. Z is 1, 1. Okay, label them. And then T is at 5, 2. So that's that. All right. Next, I have, what is it? LKJ. So L is at -3, 0. K, -7, 1. Negative 4, 4. Okay, we're good? All right, now we're going to determine whether they're congruent. Okay, so far we've learned that they're going to be congruent if all the sides are equal to each other. So what we're going to do is we're going to find the sides of each, the length of each of the sides. So I'm going to do the purple triangle first. All right, so let's do RT. Square root of, all right, RT. You see how I label it? Like really label it, because on the quiz also some people were using like different coordinate points, and then sometimes you lost track of which one you were using. So do something, okay, so like this one and this one, right? So now I'm going to do x2 minus x1, 5 minus 2 squared plus 2 minus 5 squared. That's the square root of 9 plus 9. That's the square root of 18. Huh? Well, yeah, but it's 3 root 2. Okay? All right, so next I want to do, so I did RT. Next I want to do TZ. TZ, now I'm going to take these two. So let me show you a quicker way to do this, right? TZ. Look at the x's. How much is the difference between them? From 1 to 5, that's 4 units, correct? So 4 squared is 16. Plus, from 1 to 2, the y's, what's the difference in between them? 1. 1 squared is 1. So that's root 17. Next, so I did RTTZ. Now I need to do RZ. So that's these two.
Are we allowed to use that shortcut?
Huh?
Can we use that shortcut?
Yes, absolutely. Okay, RZ, but show me at least this, right? The 16 plus 1.
Yeah.
So RZ, okay, so what's the difference between the x's? How far apart are the x's? 1. How far apart are the y's? 4 squared. So that's also root 17. Okay? All right. So let's see. So RT, how much is RT? 3 root 2. Let me label them here. Okay. TZ is root 17. And then RZ is root 17.
Oh, it's only one triangle.
Yeah, that's only one triangle.
I was like,
Now let's do the other triangle. So the other triangle, this is L, this is K and J. Yes? Yeah.
Where is the 1?
All right, so let's do JK. That's J and K. All right? All right, look at the x's. How far apart are they from negative 4 to negative 7? 3 units apart, square, you get 9. Look at the y's. How far apart are they? 3, so that's 9. Root 18 is 3 root 2. Okay, so that's JK. All right, how about JL? Let's do JL. Okay. How far apart are the x's? 1 squared plus how far apart are the y's? 4. Oh, that's 16. So that's root 17. And now let's do LK. LK is these two. How far apart are the x's? 4. 4 squared is 16 plus 1, root 17. They're exactly the same. Okay, so RT is congruent to JK, right? TZ is congruent to KL, and then the other ones are congruent as well. like this. All right? So we can say yes, they are congruent by SSS. Yeah. So this next postulate is called the side angle side postulate, or SAS. Now, here's how this works. If two sides and the included angle, if two sides and the included angle are congruent of one triangle to the two sides of the included angle of the other, then these are congruent. So take a look. This side is congruent to this side. This side is congruent to this side. Now what about the angle? The angle has to be the one in between those two sides. It has to be. So if it's these two sides that are congruent to the other two sides, the angle has to be the angle that connects those two. It can't be the angle off to the side here. All right, that's important. That's why now you have one side equal to another side, second side equal to a second side, and then you've got the angle in between. Do you see how that's SAS in that order? SAS without skipping over any parts, correct? So that's the SAS postulate. So here, which triangles are congruent? Well, it's triangle GHI congruent to triangle what? If it's GHI, which one? JKL.
What about your IHG?
So if you switch one, then you have to switch the other ones correspondingly. Okay? All right. So here, determine which postulate can be used to prove the triangles are congruent. I love these. So take a look. Three sides, congruent to three sides, that's SSS. Okay? All right. What about here?
Wouldn't that also be
That's SAS.
Is it SAS?
Wait, are you talking about B?
No, it's not. I think
which
it's
one?
SSS because all.
Okay, wait a minute. So let's talk about B. Okay, we're talking about B now.
Oh.
What is congruent between the two?
Oh, the angles.
All three angles. Have we learned in
Oh,
AAA?
no, it has to be all three sides.
So this is not possible.
Oh, well, wouldn't angle be a thing?
Have we learned angle?
No.
No. So no.
Is that a signal?
Nope. AAA is not. There, no. No, AAA does not. When you'll learn that. So,
Different sizes.
look at you go. Guess what they are? They're proportional, but not congruent. 2 chapters in, okay? Or 1 chapter.
When do we do scaling?
Okay, so take a look at this one. Take a look at what we have here. Look at how I work through these. I've got one side congruent to another side. I've got an angle congruent to another angle. And let's take a look at the two triangles here, right? You've got one triangle here and one triangle there. Do you see how you've got, this is one, hang on, Elisha. Do you see how this is one triangle and here is another triangle? All right, now, this is an angle here. So far we've got a side, an angle. But do you see how this side is one that the two of them share? So that's a third side that is congruent.
So it's SAS.
And so now with that, okay, so before you're too quick to say SAS, you have to make sure, is it two sides and the angle in between? Is it two sides and the angle that they create? Yes, so it's SAS. All right?
How would you know if it's in the middle?
So,
Because when they're connected.
okay. All right, so let's do this next one. Take a look here. I've got a side congruent to a side, another side congruent to another side, and this one side that they're sharing, okay? The way we label that is, that's the third side that's congruent, so that's SSS. All right, so let's do a couple of proofs. Lots of proofs. We're gonna prove triangles are congruent, you're probably going to have to use SSS or SAS postulates, all right? So to prove triangles are congruent, try to show SSS or try to show SAS. So first, let's write down the given here. GH is congruent to KJ, HL to JL, L is the midpoint of GK. Okay, so let's mark down what we have. This is the given. GH, KJ, HL, JL. Not only do I do that, I also write, okay, I have a side. Now, I'm also given L is the midpoint of GK. What does that mean?
In the middle.
Right? So what does that mean about these two segments? That they are congruent. So now I can say GL is congruent to LK because of the midpoint theorem. So look, okay, side, side. So now, three sides congruent to three sides, I can now say triangle GHL is congruent to triangle KJL, SSS postulate. Another way you can label is right over here in your proof. You can say, all right, this is an S, this gives me an S, this gives me another S, SSS. The good thing about this is you can see it right in the proof. The good thing about this is you can see the orientation, so you know, like if it's like two sides at an angle, is it the correct angle and so on, okay? All right, so let's do another one. RQ parallel to TS, that's labeled. RQ congruent to DS, it's also labeled. So let's write these things down. RQ congruent to TS, RQ parallel. Now, let me tell you a little secret. You guys ready? Don't tell anyone. You ready for the secret? When they give you when they tell you that two sides are parallel, or two lines or segments are parallel, they always want you to look at alternate interior, consecutive interior, alternate exterior, one of those angles, okay? They don't just tell you that for free, like for nothing. There is a reason. So, what do I have here? I have sides. I need to prove QRT is congruent to STR. All right? Do you guys see any other sides that are congruent? Leah?
The middle.
Right, tell me what's in letters. Like
Line RT.
segment RT is congruent to segment RT. What's the reason? Reflexive. So now I have a side and a side, right? A side and a side. I either need a third side or an angle.
Aren't the QT and RS also parallel and congruent because of I believe the converse of.
So we have no information to tell us that.
But because of RQ and ST are parallel.
Right, but that doesn't mean that the other two are, because they could be like skewed, like just a little bit, like right, like just a little bit, right? But how can we use the parallel lines to come up with some angles that are congruent? Harrison?
S and Q.
Angle S and Q. So we don't have an S and Q, but look at this. Let me extend this, and let me extend this. So, sorry, I wanted to extend the parallel lines. I was still stuck on what Elijah was saying. So let me extend those two parallel lines and the transversal, right? So what do we know about these two angles? alternate interior angles. So I can say angle QRT is congruent to angle STR, alternate interior angles theorem. Okay, now look at what I got. SAS, right? So I can now say triangle QRT is congruent to triangle STR.
Can't that be like
Hang on, and SAS is good enough. Okay, so X is the midpoint of BD. So let's write that here. X is the midpoint of segment BD. X is also the midpoint. X has a double roll of segment AC. We want to prove triangle DXC is congruent to BXA. I like to highlight the triangles I'm looking at. Okay? All right. So if we know that X is the midpoint of DB, I know that these two are congruent. And I know that these two are congruent as well, right? So, again, let's go back to what we were doing before. X is the midpoint of BD. What does that mean? Right? Yeah, so AX is congruent to XC. DX is congruent to XB. Whoops. What is this? This is midpoint theorem. All right, what else? We either need SSS or SAS. What do you all think? Yep. How? So far, all I have is SS. Oh, look at you. Okay, so which angles are congruent?
angle AXB and angle DX.
Correct. Angle AXB, DXC. What is this? Vertical angles theorem? Is that enough? You're sure?
No, yeah,
It is enough. We got SAS. So triangle DXC congruent to triangle BXA. SAS. All right. Last but not least. AB congruent to CD and parallel. Okay, so let's write that as the given. Okay. All right, so let's get a little strategy going here. What else is congruent here? Wait, what are we trying to prove? Ooh, we're trying to prove AD is congruent to BC. We're not trying to prove the triangles are congruent. We're trying to prove that the sides are congruent. So guess what the strategy is? Yeah.
So would you extend the transversal and you can do converse of alternate interior angles here?
Well, okay, so do you see how we also have two triangles here? So the strategy is, if I can prove those two triangles are congruent, then if you have congruent triangles, are all the corresponding parts congruent? Yes. If I could just prove that these two triangles are congruent, then any part in those triangles are also congruent by CPCTC. So first, let's try to prove the triangles are congruent. For the triangles to be congruent, I have an S. What else do I have? What else do I have, Leah?
Another S.
Where?
Line segment B.
segment DB, right? That's my other S. Now I need either another S or an I. Well, it can't be another S because that's what I'm trying to prove. But, okay, so where's the angle? Well, tell me exactly. We're now, 4 chapters in. We can label our angles. Label that angle for me.
Angle ABD.
ABD, right? Yes, is congruent to BDC. Why?
SAS.
Not SAS. That's for triangles. For angles, why?
Converse of alternating and tailoring.
Okay, so not the converse, the actual theorem. All right, so let's write all this down.
You're right.
So 2 dB is congruent to dB, reflexive property. So I had one S before, another S now. 3 angle ABD is congruent to angle BDC. Alternate interior angles theorem.
Why do you write an S?
Angles.
We have.
No, I'm just used to it. Like ever since I was in geometry, back in the day, back in the dark ages. So now that's my A, right? So I have SAS. So now I can say triangle. Okay, so we're going to try to see those triangles congruent, right? So triangle DAB congruent to triangle what? Tell me now. What triangle? So if it's DAB, huh? CBD, is that right? So DAB, where did I start? I started from here and go BCD, because look, I started next to this one, right? Like next to this angle. So BCD this way. Okay.
What is AH?
That's all. Will that be SAS?
It's SAS, yes. Okay, now that I've proved the 2 triangles are congruent, any corresponding parts are also congruent. So I can say segment AD is congruent to segment BC by CPCTC. Okay? This is why we had to learn CPCTC. And again, you can't just use the same letters in another order, right? Like it doesn't work. This is no credit, all right? It's got to be in the correct order. All right.